I just wanted to join you for 1 second, Robert. So this is our colleague, Robert Mustacchi. I feel, Robert, like you have a long history of like on the fly putting together dtrace.conf presentations. I don't know if this is accurate, but I think you've been presenting at dtrace.conf as long as there's been dtrace.conf. And
Nor in 2008.
okay, fair enough. Okay, good. When you were like actually a student in school.
In his defense, he had a
Yeah.
class.
I mean,
I wasn't there.
right. Um, but I'm looking forward to get another on the fly put together presentation for teachers to long time.
Yeah, I mean, so I think where Rye gave us a lot of beautiful things that exist, and his was, all no slides, all demos, which is great. We're gonna go to a world, talk about worlds that could exist or might exist, and aren't that hard to get to. So, for this to kind of talk about, we're gonna first talk about elves. So, we're gonna ignore the questions of what language we're speaking here, but really the thing about dtrace is built around elves, right? Everything that it reads, everything that it scans are elf objects here and on most platforms. None of us support A.out, and the one exception would be Mac OS, which does scan non-elf objects, but for as far as we are concerned, that kind of doesn't exist. Why does this matter? Like FBT and PID, the way we get all those names that we scan, the symbol table. CTF is, stashed also in an elf section. Ben and Adam were talking about USDT, and what did we do? We stashed more data in an elf section. Okay, so elf is here. That's great. So let's talk about some things that people like to do. So like these are two examples of code, one in a language that you probably dislike and one in a language that you like. One, they're on the right, you have Dropshot, and the left you have there. dtrace is great. You can usually get function entry, get some arguments. But there's all these things in between. We have all these pesky local variables, all these things there. So also, if your language decides that, doesn't love the System 5 ABI, you're not getting arguments. Args is kind of useless. So this a while back, over 4 years ago, there's a little prototype we have of using locals. Same way you have foo points to, or this self, the different clause local variables. Conveniently, everything following and preceding an arrow is reserved by dtrace as a keyword, so you can't use it. This also got us out of when we first had the bad idea of using locals as an array. But what this meant is that you could actually put a PID provider probe pretty much anywhere in there, and you could get access to your variables as long as you didn't care about the type. But you got to use 64. And that's pretty good. And what is this? Okay, what ended up happening is that this was actually all using Dwarf under the hood. This is where the Dwarves come in. And it turns out that we had accidentally built a small compiler. Dwarf, is a wonderful and terrible format at the same time that encodes all of this information in its own effectively virtual machine that basically looks very complex, but in practice, actually, you only really need like 2 or 3 things that gets you 95% of what you need, which is basically dereference this register, which surprisingly sounds like the word uregs, and then, copy this thing in, which, you can just use copy into dereference. So there you go. That gives you a whole bunch. But what this ended up doing was saying, what if we could go and basically take the existing D that we had and basically just, insert a little bit of, magic in the compiler and basically transform one bit of D into another bit of D. So instead of having local to foo, you would replace that with, copy in uregs of da. Okay, so this is here. There's a prototype of this. It's great. So that wasn't really great because it's unfinished and sits abandoned from 2020. But let's kind of go into what other things, what's here. What other things? One of the problems is Dwarf itself. You can probably virtually raise your hand if you actually on your production systems have binaries with Dwarf. I'm guessing that most folks in the chat right now would say they don't. Even if you had it, it's also not included in core dumps. There's a whole bunch of ways that you can actually get access to that stuff through third-party things. But if you've ever tried to enable the Debian or Ubuntu source repositories to download things, then you have your own mental scars there. So there's this kind of fundamental challenge here. There's some things we've done to enable this. Actually, ironically, back in the day, you can actually separate all this Dwarf into a separate file. And actually for the LX zone, we actually added a whole bunch of work to actually follow all that information. So you can find a symbol table because everyone decided that your symbol table is too big for you, and what's the use there? So let's talk about some other things that if you basically take what's here and use some of the dwarf information, there's actually a lot you can do. And other things have already done this. It's just a matter of actually putting these things together. So, for example, if you run stack or ustack, you get all these kind of nice symbols and frames. But what if you could actually just, this is really this set of files at these line numbers. So you can actually just go with a fairly straightforward transformation, look up an address and transform it into source line information if you have this dwarf here. Just like in the last case, everything we did there was basically looking at using dwarf at compile time. Here, this is all just using dwarf at translation time. The same thing is kind of true with inline functions. There's a whole bunch of dwarf information about where these inline functions are. When you use stack or ustack, effectively the kernel is doing is going to walk the frame pointer, basically give you a whole bunch of return addresses, and just pass down a whole bunch of addresses to userland. Nowhere until you get to userland, that's the first point that symbols actually show up. And that's where we start, walking symbol tables and looking at all these other things to try and turn them so that humans understand. But compilers, especially Rust C and others, really love to inline functions. So if you actually have the dwarf sitting there, you can actually augment that ustack and stack information with all of this information. If you've used humility, I think, Brian, you added that in humility at one point, or someone did, walking all the inline functions in dwarf. And so this is here. It actually, the good news, you don't even have to change anything about how you instrument it, how you do what you do in probe context. It's literally all just post-processing in libdtrace or moral equivalent. But we can actually do something even crazier. So, one of the things is hey, if you have ever actually tried, I guess, kind of show of hands, who in the room has actually gone and used the instruction offset to the PID provider and figured out what offset to use in a way that didn't feel gross? Anyone?
We did feel gross. Come on, we're gonna qualify what you're putting on here. Yeah, I felt fine. I felt good.
Man, good.
Okay. Right. It felt like it had utility.
Yeah. No, but so one way to visit, what if you could actually phrase that a different way? Especially because, when you're working here, you're saying, okay, I've got a function. It may have been instantiated multiple times. It may actually show up more than once in my address space. Actually, the same way that people like to set a breakpoint in an IDE, what if I could actually just set a probe point in that same way? So here you kind of have a very vague sketch of what this might look like, where you're specifying a PID that's there, the file in line, and then, which instances. And then unfortunately, there's a challenge that you have. One line of code translates to, unfortunately, many instructions. A simple thing may not actually be that simple. Or make something get inlined in its place. So you need someone to disambiguate that. So this is kind of throwing out just one way of what that might look at. But then this kind of also go the other way. Again, if you kind of have this information sitting around. But let's go one step further. So, there's a big after here, which is type information. So, for doing kernel debugging and other stuff, CTF, which is the compact C type format, has been essential, right? The fact that you can just use print, you can look at arguments, you can look at semantic members of structures is actually one of the most powerful things that dtrace gives you, is that you can look at this stuff in situ, you can create predicates around it. You can actually ask questions, such as only fire this probe when this part is true. So sometimes we've used this to look at parts of the TCP state machine, or just error counts, or you name it. Actually, it's kind of something that ends up, there or not. If you listen to the USDT talk earlier today, we kind of had a very successful way. We found the max power way to basically get types, type structures into programs. But that's not, but why are we kind of constrained to that? And right now it's because we're kind of constrained to, we know about how to use CTF. The D language itself, inherits kind of the C type system there. But what if we could actually, what is CTF but converted dwarf? in some ways. Um, so while there were some prototypes in the past of converting dwarf to CTF on the fly, that only really works if your dwarf looks like C. But if we take instead of trying to say, how can I change D the language to basically allow me to declare types that are different in every different programming language? What if we could instead just, augment print dereferencing and the kind of the arguments vectors to understand existing arguments, to understand existing types that are in there? Then that kind of gives us you could then print, whether it's a Rust structure in a enum, something that from an entirely different language, as long as it's describable in Dwarf, then you could go there. That's true for Golang and a ton of other stuff too. So that's kind of the next kind of somewhat out there bit. The last bit really is stack unwinding. This is kind of, I'd say, Durin's bane. We've delved too deep and we decided that, hey, frame pointers, get rid of them. That's just kind of the unfortunate reality. Now, this basically translates into a problem that actually looks a lot like a UStack helper. So a UStack helper basically kind of does what it says in its name. It basically is a different D program written in D that helps you that allows you to decode a stack frame and do that. So there have been UStack helpers written for Java. Dave wrote one for Node.js. I think there have been others, maybe other UStack helpers.
Yeah, the
Python,
Python Node and Java at least. Like PHP.
Yeah,
there's a PHP use cycle at some point.
So this problem,
They're esoteric.
there's a lot of challenges here because we have on the one hand Dwarf, which has a very complex VM for describing all this. That ends up creating a lot of data, and there's a lot, effectively at every different instruction, based on context, there's a whole different way to unwind. That's why people like using the frame pointer, because good news, I can ignore all of that. But there's been a lot of experience on getting all of this in eBPF land and trying to use different things, whether it's using the exception unwinding. But there's basically a lot that one could explore, taking the whole idea of basically the fact that we can already compile some subset of Dwarf into D, transform this into a very crazy UStack helper or something else, and passing that on. So, whether compiling all that into D for all the different libraries will make sense or not, how do you do that for different programs? You have to be very targeted. But there's a lot that you can actually start to do if you kind of take a step deeper into kind of that integration. The last little bit here, I'll kind of just close on is just symbol servers. All the part of the challenge with all this is all this works if you have Dwarf. We kind of said also no one has Dwarf. For those who have worked at Microsoft, they kind of espouse the glory of the symbol servers they have and its tight integration into Visual Studio and everything else. But trying to figure out what does that look like? How do you kind of build that into a first class way? So it's not just, it's actually in these tools and not just a object of the package manager. Or how do I point this at my even if this is harder to use in production, how can I use it in development to help speed up? Because there's still just as much dtrace in development as there is in production. So really, that's kind of all I got. This is kind of a bunch of, things that could be or might be. And, I think the thing I want to call is that none of this is actually all that complicated. I think there's a lot of things where they've been, things have been kind of like, you kind of see it's like, oh, well, it's not in CTF or it's not, it's in this other thing. It's in this other binary payload. And I just never looked at it. It's only, that's only the realm of, my source debugger, but it's actually pretty straightforward. It's just, just a bit of work to kind of get them integrated and with there, you can do a whole lot. So there we go.
That's awesome, Robert. Very inspiring. The things to do. Also on we talk about walking flexibly hidden frames to the UStack helper.
Yeah.
We also maybe to mangle names. I know
Yeah.
pipe through the C++ fill. I pipe.
Yeah. So so like Apple does automatic demangling. I have a prototype of automatic demangling. The big question, I had some outstanding questions for folks around semantics.
Yeah.
So that's that. The bigger, then the next thing is also how do I specify unmangled names in ProPoints? And I think that would be one of the other kind of big things is just getting some syntax for that, because that will help people be able to phrase it in a way that they can recognize and, you know, is somewhat usable.
Yep. And it would be great to be able to answer when it makes sense. There's some things that are really hard to understand for us against their closures and so on. But
But in theory, with a source provider, you should be able to basically, because the thing is, the dwarf can point you to where all that has been compiled into.
Right.
So there's no reason you can't say instrument these. It's just that reality might be more complex if there's like 10 different instances.
that's great. All right. Well, thank you very much. And the locals points prototype. That's the branch that's still,
It's in a branch. It's on the internet.
it has not joined the 2016 dtrace.conf videos in a watery grave.
Not unless GitHub is started to delete data for me secretly, but
Okay.
yes.
So given our 4-year cadence conference,
Great things.
what are the chances of some of this being reality?
Oh, 2028, it's going to be a big year.
Big
More- I can tell it already.
We'll give a
Yes.
good review at that conference.
Yeah. We'll see how much time I'm allowed to actually can make for working on this stuff, but
Yes.